So the in-cross problem gave us a potential, gave us an equation, told us we have a potential that looks like this. V, I think this is the equation for potential of a dipole, which is two poles. So this is something that we observe. This is actually a real-life physics equation. X divided by x squared plus y squared plus z squared. All of that raised to the 3/2 power. So we're given an equation. Anytime we've been given equations in physics problems, that kind of tells us right away, oh, I'm not just going to plug and chug some stuff in. I'm going to have to do some calculus. So this kind of points you to using a calculus definition to find what you want to find. And what we want to find is the electric field caused by that potential at all positions in space. So I want to find what's the electric field in the x direction, the y direction, and the z direction. How is the electric potential related to the electric field? E and V, how do they relate? Go ahead, Carmi.
The vector E equals negative that weird delta thingy.
Vector E equals negative weird delta thingy.
With an arrow on top, and then V.
V.
Yeah.
The electric field is weird negative delta thingy times V. Weird negative delta thingy is called the del operator or nabla operator. It is the partial derivative with respect to every single direction. So we can write this out very, very explicitly. E is equal to negative dv dx. But what's weird about the d's that I'm writing? Those aren't normal d's. What are they? Kind of curly d's? They are partial d's.
Partial.
These are all partial derivatives. Negative dv dx plus negative dv dy plus negative dv dz. And each of these partials gives it in the respective direction. Okay. So this is the expanded form of this. Same exact things. Give you an idea of how old I am. I am so old, when this came out, this equation, when I learned it, this operator, it was called the del operator, and it was really a big joke amongst all physicists and physics students that were learning this, because the really popular computer at the time were Dell. Anybody ever seen these commercials? They're really old. The dude, you're getting a Dell guy. Look him up. I think he was like arrested for homicide in Florida or something a couple years
Oh,
ago.
wow.
Of course, in Florida. Right? All right, E equals negative del V. So we take the partial derivative of the potential V with respect to x, with respect to y, with respect to z. Partial derivative. What that means is the only variable in the problem is whatever's in that denominator. Everything else you can treat like a constant. So let's see how we do that. Let's find EX first. EX. That's going to be negative partial derivative of V with respect to x. And it'll be in the I hat direction. So we have a negative partial with respect to x of this nasty, disgusting looking thing. It's like x divided by x squared plus y squared plus z squared, all raised to the 3/2. That looks like a pain in the butt. What rule do I have to follow to take this derivative?
Disregard every other variable that's not x.
X is the only variable, but this is set up a certain way. This is a fraction, right? How do I take the derivative of a fraction? There's a rule for it, isn't it?
Minus.
Anybody remember the rule for it? Nobody ever remembers this rule, the quotient rule. The quotient rule sucks.
Isn't it you subtract? Or no?
It's ho-de-hi minus hi-de-ho over ho-ho. Okay? Or sometimes they teach low d high minus high d low over low low or something like that.
Yeah.
I never remember that. I remember the product rule. The product rule is so much nicer, so much easier. First times the derivative of the second plus the second times the derivative of the first. I can remember that. So I'm going to rewrite this so that I can use the product rule instead of the quotient rule. This quotient rule sucks. Now, all the big fans of quotient rule are going to come after me on YouTube. Bring it. EX equals negative d dx in the I hat direction of x times x squared plus y squared plus z squared to the negative 3/2. That up there is the same thing as this down here. These are the same thing. I just used a negative exponent to bring it up top. So now I can use the product rule. Product rule is first times the derivative of the second plus the second times the derivative of the first. So this is the first piece of my equation. This is all this back part is the second. So I can take this derivative. And x is the only variable I have. So I take the first variable. What's the first thing? X. So I'm going to take this derivative. EX equals first. Then I have to take the derivative of the second part. I have to use the power rule. How do I take the derivative of all that second part? Did you ever learn the...
Wait, don't you add...
Yeah, I don't think we ever learned this. Doesn't sound like we learned this.
It's confusing to go back and forth from integrals and derivatives.
So what we do, to take the derivative of something that's raised to an exponent. It's very similar, right? You take the exponent and bring it down front. Yeah. We're all good there. We can remember that. So I have negative 3/2. And then I write down the exact same thing that I already have. I write all of that back down. Everything that's in the parentheses gets carried down. So I have x squared plus y squared plus z squared. And then the exponent, I need to subtract 1 from it, and then that becomes my new exponent. So negative 3/2 minus 2/2 gives me negative 5/2. Then, the thing that people always forget to do, you have to come to the parentheses, inside of the parentheses, and you have to take the derivative of everything inside the parentheses. So what's the derivative of x squared plus y squared plus z squared with respect to x? 2x? Okay. What happens to y squared? The 2y? No? As well? So say it louder. The air conditioner right here. Doesn't have an x in it, so it's just constant. It's just 0. How about the z squared? No x, just goes to 0. That is the derivative of the second. Okay? So that's the first variable times the derivative of the second. Now I need to take the second and multiply it by the derivative of the first. So I take that second part plus x squared plus y squared plus z squared. Raise it up to the negative 3/2. Then I take the derivative of the first variable. What's the derivative of x?
1.
Just 1. And what direction does all of this go? It's EX. So what direction is it going?
I have.
I hat. Because that's the x direction. Did I just lose a negative? I did lose a negative. Put a negative right out front. I'm always worried when I talk about teaching calculus and talk about derivative of x, because the more you say derivative of x, it just sounds like you're slurring your words together, so I sound a little bit drunk. If I get pulled over for a speeding ticket someday, I'm gonna be explaining how I wasn't speeding. I was just using the derivative of x with respect to time, and the officer's just gonna arrest me. All right, that's ex. Let's find ey.
Do we just leave it like that?
Sure. ey is negative derivative of v with respect to y. So let's take negative d dy of, and we'll include that j hat, of x times x squared plus y squared plus z squared to the negative 3/2. Still got the negative. Take the derivative now with respect to y. I have the first variable times derivative of the second. Come in. Have a seat. So the first variable is x. That stays. Times the derivative of the second. What's the derivative of all of this junk over here? How do I do it? What do I do first?
Leave out the constant.
First thing, to take the derivative of all of this.
To multiply.
We did it up here.
Bring it down.
Take the exponent out front. Bring it down. Negative 3/2. And then go back to what we just did. And what did I do next? I just wrote down everything that was in the parentheses. X squared plus y squared plus z squared. And then I take the derivative and raise that to the negative 5/2. And then I take the derivative of everything that's on the inside of the parentheses, where y is the variable this time. So what's going to be the derivative of x squared plus y squared plus z squared with respect to y? 2y. Boom. We're brilliant. Okay, so that's the first part. Looks very similar to this, doesn't it? Only thing that changed was this derivative right in there. Okay, then I need to add the second part. Plus x squared plus y squared plus z squared to the negative 3/2. And then I need to take the derivative of the first part. The first part was x. So what's the derivative of x with respect to y? 0. So this is a big fat 0. And what happens to all the back end of this?
0.
Just goes away. What direction is this going in?
J hat.
J hat. There's your EY. Now I want all of you to work at your tables and figure out what's EZ. I'll give you a hint. It's negative dVdz in the K hat. When you have your final answer, put it on the whiteboards.
Just the final answer, or do we have to solve it on the whiteboard?
Just the final answer on the whiteboard. You can work on your own sheets, iPads, papers.
Same thing, so it's like egg.
Yes. And we're also going to get like a 0 for all of this other stuff because it's x is 0. Okay, so this would be negative x, negative 3/2 of x squared plus y squared, which is d squared negative 5/2, and the derivative of that would be 2d. And that's in a k hat. Yep.
Why does this smell like yogurt? Like what? Yogurt. Yeah.
I was gonna say, if it smells like burgers, that's me. No, I don't have yogurt in there.
No, it's this. The marker?
Yeah.
It might smell like that.
Maybe
Maybe somebody dipped it in yogurt.
works pretty well for something that's dipped in yogurt.
Imagine.
Because guys were my hand. You want to rewrite it?
No, because my text look easy.
You look concerned with the pretty much.
It just looks like the back.
I didn't know I had oranges.
So we all agree.
No, that'd be okay.
Yeah.
Not look
Yeah, I got that.
I don't want to put it on your computer.
Oh.
It's like gonna slip out of my hand.
Oh, yeah. It's just a flip version of that, but a
Oh, the second part? But then when we take the derivative of x is 0, right? Yeah, and then we're gonna multiply it by the whole thing, so it's gonna end up being 0.
All right, let me see what you got. Negative 3 halves times x squared plus y squared plus z squared to the negative 5 halves times 2z in the k hat direction. Okay.
We're gonna go around repeating that.
Yep.
Yeah.
my A's are so confused. And I already talked to Oh, for the things out of fame. Oh, okay.
Don't worry, I'll eat for you.
How is that gonna keep me? Oh, really? That's nice.
But I can always eat.
Yeah, that was my
Sam,
I thought you were like,
he's so hungry.
because it's like the same thing, but I thought you were
I'm actually gonna ask him to use the microwave now, though.
I used to, I was so bad.
All right.
I wanted so badly to.